So we're gonna take our actual data and pop it over into a new tab. So I'm gonna go new tab. I'll just leave it here for now. Rename it Sine. All right, Sine short for sinusoidal. Now I want to bring my actual data over. So high temperature, low temperature. So I can just do a copy paste if I'm done collecting my data, or I can use my cell references. So I'm in B1 here. So I will make a note that this is a sinusoidal, just so it has a similar format. It's not going to be very similar, but based on what we have on the other pages, it would just kind of have the similar look and feel, right? So I had it highlighted in yellow, for example, so just for consistency. So equals all data B1, drag it over one slot, drag it down, and just put it way down there, just in case I end up adding more data down the line, which I won't do because I've finished collecting data on this topic, but for your purposes, it might be worth it. All right, so I'm just gonna kind of clean it up a little bit. We like it centered. Me, I guess. And I don't like the cutoff, so format, wrapping, I'll just wrap it. All right, now I'm gonna go into my other activity, and I'm gonna pull what I have for the sinusoidal. And remember, this referenced Desmos, so I'm gonna have to go into that app. All right, I'll just put it right here, for example. I need a link. This is no longer valid. I still have my setup here, my drop downs, and if it's a no, it's likely appropriate. If it's a yes, it's likely not appropriate. Right, that's for the residual plot, but I do need to go to Desmos and pull this data in. So actually, let me copy all this data over. Command C. I'm typing in desmos.com. Open the graphing calculator. Just paste it right in. Good looking graph. Now I want to do my sinusoidal regression. So y1 tilde a sine parentheses b x x 1 plus c plus, I'm just batting 1,000 here, plus d. And so I have my r squared value, which is a 0.721. This really does not look like a sine wave, right? But if I zoom out a lot, you could see that it's got a curve to it. If I really zoom out, I'm just actually trying to zoom out until it turns around on itself. This looks like it's a massive, based off of the A and the B values, it's going to be pretty massive. So if I want to get back to the original zoom, I just hit the little home button. But I also want it to be consistent with what I had before, which has values in the 70s. So let me go to the graph settings and just change it back. If you ever get into a jam with the zoom, you just change it back here. From the X value, 0 to 100 ought to do it. Y values, 0, that's not a 0, 0 to 100. All right, so we have a good looking graph here. All right, it doesn't look like it's accomplishing anything really more than a linear model would, but again, this is my data, so you never really know. All right, so if your data is periodic or cyclical, then it would make more sense for you to do a sine wave. What I'm trying to do is for everybody's spreadsheets to have all the likeliest possible transformations and regressions, so that when you're looking at your data, you say, okay, well, I didn't need a log, I didn't need quadratic, I didn't need linear. Oh, look, a sine function works. So that's the idea there. All right, so I'm going to pull my r squared value, put it into my spreadsheet. We didn't look at the residual plot yet, but let me get that Desmos link. All right, so the share link, copy. So your choices are to create a zoom that will show both of the regression and the residual plot, and then do the share, or create two separate shares, one where you zoom in on the regression and one where you zoom in on the plot. The one thing I got to caution you about is with Desmos, it won't automatically update when you increase the data. When you put more and more data into your original spreadsheet, this doesn't automatically get updated. So you'll have to append this. You'll have to add on to it. All right. So I'm going to take a look and see where my residual plot's going to go. You know what? I can get it all in one zoom. So I feel pretty good about this. So I'm going to copy this now and paste it right in there. And I don't see a pattern in that residual plot. We'll take another look. Yeah, looks pretty good. So I'm going to say no. So this model is likely appropriate. And like I said before, I didn't think it did anything more than a linear model would do. So I can compare this to that. The linear model had a 0.721 roughly. I have a 0.721 for my sine. Exponential, not as good. Quadratic, 771-ish, so same neighborhood as sine and linear. And logarithmic, same. So I kind of look at it always as the tie goes to the simpler function. So in this case, I'm looking at all these different possibilities, and I really would not go past linear because that's the simplest function that we have, and none of the other models help me to capture the relationship between the two variables as well as the linear model does, at least for the amount of data and the span of data that I collected. All right, so that's all we're looking for the sine model. I need to be able to click on this and see your Desmos, right? And you'll want to be able to click on it and see your Desmos, because when you go to put your final project presentation together, you're going to want to have things that you can call as visual aids to help explain or to prove or disprove your case, or whatever your claim is. All right, so there you go.